square root of x. Given a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use any built-in exponent function or operator. For example, do not use pow in C++, or the square root of 4 is 2, so return 2. Okay, so we round down and we cannot use a built-in function. We read it. Question was the negative part, but I guess that was answered. Example we looked over. Edge cases. Obviously, if it's a 0, then it's probably a 0, if that counts. What is another edge case? I feel like I should not even Google how to do algorithm part here, because I feel like that's the entirety of it. I wonder what topic this is supposed to cover. It is a binary search, huh? I feel like that's a pretty good hint. You split it in half. I don't quite recall the syntax for binary search, so let me look it up. Okay, so binary search, some sort of while loop. X greater than 0, x. How do we know which one is the closest? Something I would like to try is divide it in half. So let's say if a number is 10, divide it by half. So 10 divided by 2 is 5. So we try to multiply that. 5 times 5 would be 25. Okay, time limit exceeded. As long as x is greater than 0, we start by chopping it in half and calling that y and try to square that, right? So y times y is greater than x, then that's not a square root. So we try it again. Could do like if y times y is equal to x. No way that this is correct. I don't think this is gonna work. Time limit exceeded. Problem is, what if that doesn't work? So in theory, we could go to like extremely small decimal numbers and trying to continue. So let's say it's 20. 20, then y would be 10. 10 times 10 is 100. So 100 is way bigger, so we divide it by half. 10 is greater than 0, so y is 5. 5 times 5 is 25, which is bigger than 20, so we divide 10 by 2, which is 5. So let's say x is 5, y would be 2, is 4, that's less than 5. How do we go about finding the right decimal points after that? Because 4 is less than 5. I told myself that if I'm thinking too much, then there's gotta be an easier way. But this is like my initial reaction of how I would go about it. I get that it's not the right way to do this. Binary search. I'm not sure. What do you do here? Okay, 22 out of 100. Edge case was right. Intuited that division halving is relevant. Left honest comments about where your logic breaks down. That self-learning is extremely valuable. You mutate x mid-loop. Your comment flagged this. Yes, it's critical error. X is your input and you're destroying it. The loop logic doesn't converge correctly. Okay, so when there is a binary search, we need the low and the high. Voids overflow. Y high at the end. When the loop exits, low is greater than high, meaning low square just exceeded x. So high is the last value whose square was less than or equal to x, which is exactly the floor. Looking at the answer key, we took care of the edge case, binary search algorithm that I'll just have to get used to and memorize. You have low and the high, and you set this while loop in action with a condition of low less than or equal to high, which ensures us that we will eventually come to an end. Middle is low plus the difference between high and the low. I would think that the middle is low plus high divided by 2. The only line that I am having trouble fully grasping is this one. Could you elaborate on this line, please? Both formulas give the same mathematical result, but they behave differently in memory. Problem with low plus high divided by 2. Low plus high is evaluated first, and that addition can overflow before the division ever happens. even though it's the same thing, the way that computer computes this equation changes drastically just because of the difference in the order of operation. Teach me what overflow means. Think of a variable like physical box with a fixed size. It can only hold so much. When a value grows bigger than the box can contain, it wraps around to a wrong value. That's overflow. In C Sharp, an integer is stored in 32 bits, which means it can hold up to about 2 billion. When you exceed the max, the value wraps around to the minimum and keeps counting up from there. At the hardware level, integers are stored in. So today was problem number 69, square root of x. Trying to find square roots without using built-in function. And it was interesting to realize that finding a square root at its core is actually a binary search type of problem. Trying to solve problems without those fundamental data structure and algorithm concept when the problem is built around it makes you realize that you really have to lock those down in order to make progress. But in a way, I think it is a amusing journey to look at a problem from novice or beginner's perspective when there are those set answers and you're just trying to figure out what the right way to solve a problem is. While it doesn't feel great to be wrong on most of the problems, I think it's a very interesting experience to learn about all these problems that you take for granted. The initial mathematician or whomever computer scientist that encountered this problem and came up with their own answers. It's interesting for sure. Thanks for watching and hope you guys had a great weekend.